My name is Maxwell Ames, and I'm a Technical Solutions Manager for TPM's 3D Printing Division.
Hello, my name is Lee Peace, and I am a TSC on the AEC side of things here at TPM. And today we're going to talk about 3D scanning, both AEC scanning and mechanical scanning. We're also going to talk about how these can be used in conjunction with each other. TPM is a Leica reseller, and we offer reality capture as a service, including scanning and modeling. We are also a Leica reseller, so we can do the scanning for you, or we can sell you the scanners. We are also a Artec scanner reseller. We use Geomagic software and offer scanning, reverse engineering, and 3D printing of parts as a service. After a long, extensive process of elimination, TPM's laser scanner of choice is the Leica product line. Our main scanner is the Leica RTC 360, which offers the most accurate and one of the fastest scanners on the market. It is our most used scanner. The newest scanner from Leica is the Leica BLK2G0 Gen 2. It is the fastest terrestrial scanner on the market, using Viz technology to always keep track of where it is while scanning. It scans at a rate of 680,000 points of measurement a second. Next up is my personal favorite, the Leica BLK2Go. It is a handheld scanner that uses Grand Slam technology. That's simultaneous location and mapping. It always knows where it's at while it's scanning using LiDAR and visually with one of its 3 cameras. With just a press of the button, using the RTC 360, you're sending out 2 million points of measurement a second. The RTC sends out 2 million points of data a second. Depending on the level of scanning, that's 56 million and 204 million points of measurement a scan. Both it and the BLK2G0 Gen 2 use Viz technology so that it always knows its location while scanning. As you can see on the picture, on the left-hand side are several scan setups that I have already taken, and when the scanner moves, it knows where it is for its next location, saving time both in the field and the office, linking scans together. After a scan, it will take photography with its 36 megapixel camera. It captures HDR photography and stitches each point of measurement with a color, creating an amazing point cloud. As you can see here, the 360 photography can be viewed later. The RTC 360 can also scan in complete darkness. It can also scan without photography. Here we see the point cloud data by itself without the photography. Measurements can be gathered from the point clouds using the TruView software that is a free software from Leica. It can be as simple as clicking 2 points to get a measurement. The BLK2Go, the faster way to scan. The BLK2Go is a handheld scanner that uses SLAM technology, that's simultaneous mapping and location. As you're walking with the scanner, it is constantly grabbing points of measurement up to 420,000 points a second. It is also taking photography with one of its 3 cameras that it has mounted to the front and the sides. With just a few walks, you can map immense areas of indoor and outdoor space very quickly. It has a range of around 80 feet from the scan point. And as you can see here, you use it in conjunction with a cell phone to always know where you are in the scan and to make sure that it's getting the results that you want. Once uploaded to a computer, the scan data can then be seen in its colorized form, and flybys and measurements can be taken from this data. We at TPM combine the 2 technologies, using the accuracy of the RTC and the speed of the BLK2G0 in conjunction with each other. We have a few common use cases for point clouds. This would be any project where there are pre-existing conditions. Any type of architectural renovations that need to be done can be scanned, and then you have accurate layouts. Any type of piping can be scanned and then modeled, so you have accurate layout of the piping. Anything that can be seen can be captured. For a demonstration, we recently renovated our own additive manufacturing lab to make sure that everything was going to fit where we needed it. I scanned the machines and turned them into a simple mesh. I did this for each machine. We then scanned the new location that they were going into. Using the Leica TruViewer, the free software, we were then able to import each model and place them where we were planning on putting them, making sure that each machine was going to fit. It offers an inexpensive alternative to modeling a machine in SolidWorks, and it can also be used in SolidWorks. We offer several delivery methods for the point clouds once a scan has been processed. We can deliver the point clouds to them by themselves. We offer modeling training, which is teaching you how to model the point clouds yourself. And we also offer a modeling service. Modeling is done to specific LODs. Architectural, structure, and MEP can also be done at different levels. When we are capturing plant layout, we can go into as much or as little detail as you would like. We make meshes from point clouds. This is a simplification of the data. It's turning it into a mesh. That way we can make it easier for you to work with in SolidWorks. This is a scan that we took of a local airport that had a Cessna 130 out front. We were able to trim the portion of the point cloud down to what we wanted it. And then we were able to turn that into a mesh. If you notice, the blue points are where the program filled in the scan data from the points that we could not get to from the ground. Another fun thing about point clouds is that they can be viewed in virtual reality. This allows for enhanced BIM and VDC coordination and calibration. If you have a big enough space available to you, you can easily walk around in the point cloud on a 1-for-1 scale. You can hop around from setup to setup and view the photography that has been taken. If you don't have an area big enough, zooming around is always an option. Measurements can be easily taken in VR. And point clouds are not just a file type that's only used to be converted into something else now. With several programs, it's able to natively take point clouds now. Twinmotion from Epic Games is one such program. Twinmotion is from the makers of the Unreal Engine, and it's quickly become my favorite visualization tool, especially in outdoor environments where its ability to output realistic renderings is an amazing process. Twinmotion also has tools for the output to VR and 360 videos. Something to remember is all of this data was actually captured with a combination of BLK2G0 and RTC. We did not use a drone for any of this data.
Good afternoon, everyone. Today, we're going to go over how to work with large scans. I'm going to show you a couple different demonstrations of some jobs that we've recently done utilizing the Arctech Leo. The Leo can handle large file sizes, but once it becomes too large, it becomes a processing problem, and we end up spending a ton of time with these manufacturing scan projects. This semi-truck job is a perfect example of that. The volume that we scanned was about 12 cubic yards, and the scan time took about 45 minutes. The processing time, however, took about 2 weeks. The accuracy needed for this project was 1 millimeter. Another job that we did was a boat top scan. The area that we scanned was above the cockpit there on the boat. The volume in total for all 4 pieces was about 18 cubic yards of scanning. The scan time took about 4 hours, and the processing time took about 3 weeks. The accuracy that was needed for this project was 1/16 of an inch. So what I'm about to show you now is a scan of this of this tank. What's different though is that we're going to be combining the scan types. We're going to be combining the scan of the Arctech Leo as well as the Leica RTC 360. The total volume for this project is about 24 cubic yards. The scan time is about 2 hours, and the processing time is also about 2 hours. The accuracy needed for this job was about a 1/16 of an inch. So the first thing that we did for the tank was that we scanned key areas that which we needed high detail. So I've got 4 pictures here of 4 different sections. I have 2 different cogs scanned as well as 1 wheel. And then up front in the tank, we scanned the headlight area, which is on the front right. This is the tank scan from the RTC 360. Keep in mind that it captured the entire tank. Now that we've captured both scans, it's time to combine the data in DesignX. DesignX has an automated tool called Align Between Scan Data, and all we need to do is to click Common Reference Points on both scans, and DesignX will automatically align the scans. Once we've aligned the scans, we can then extract geometry from the different scans. So on the left-hand side, you'll see the picture of the full tank scan. That was completed with the RTC 360. On the very front and back of the tank, you'll see 2 different areas in white. Those areas were scanned with the ARTEC Leo. What we're doing here is we're extracting planes, vertices, and axes from all of the scan data. We can even extract different contours, and DesignX will automatically recognize if they are specific shapes. So for example, on the screen there, that large purple area is a free-form surface. For this particular example, we wanted to extract the geometry of that free-form surface and then import it into SolidWorks for more reverse engineering. With DesignX, we can perform a mesh fit, which will fit a parametric CAD surface on top of that scan data and then extract out that surface data. Here's a picture of the end result of the mesh fit. That surface you see in yellow there is a parametric CAD surface. And just as proof, here's that same parametric CAD surface in SolidWorks, and we are doing a extrude up to next. The end result of that extrude is on the right. So, in summary, here are the results of the projects. With 10 projects a year, we are seeing about $92,000 in saving simply from just using the right scanners. So, for the percent change of just using the Leo versus the RTC 360 and the Leo, we see about an 87% reduction. For the processing time, we see about a 97.5% reduction. For one specific job, we're seeing just shy of about $10,000 for the potential savings. With 10 projects a year, that's how we get our $92,000. Thank you for attending our brief presentation on TPM's AEC and manufacturing 3D scanning solutions. If you have any questions about what you've seen today, please feel free to reach out to us and we'll be more than happy to connect with you. Thank you.